Selective soldering is a process to solder individual through-hole components onto a PCB. The machine includes a flux spray, preheater, and a soldering pot that feeds a solder fountain. The solder fountain, or head, moves to the position to solder from below the assembly. Compared to manual soldering, this process is faster, repeatable, and leads to a better result. A selective soldering machine uses a single head that moves to the point where the solder needs to be applied, and leaves the rest of the board untouched. For effective soldering, components do not need to be glued to the board when soldering. We use less flux and solder, and there is no need to cover parts on the board with a peelable solder mask to prevent solder deposition or heat damage. We program the machine with simple point and click programming. A canvas with the image of the bottom side of the board is loaded, and we indicate the points and route the flux sprayer and solder head need to follow. At the end of this process, the board exits and the process starts again with the next board coming through the conveyor. Before the invention of the SMT, or surface mount technology, all components were assembled to the PCB with leads going through component holes into the board. This technology dominated the industry until the end of the 80s. Today, most components placed are SMT components. You could think that THT, or through-hole technology, is now outdated and avoided where possible, as SMT is more efficient, cost-effective, and adapted to denser board designs. However, THT offers specific benefits that keep it relevant. The bonds created between THT components and the board are far stronger than SMT bonds, making THT the ideal choice for components that will undergo mechanical and environmental stress or high heat. In case of prototyping, THT components are also easy to change, making them perfect for testing and hobby users. There are disadvantages too. Through-hole components are much bigger and the component themselves are on one side, but the solder joint is on the other side, so using space on both sides of the board. The assembly process is not automated, depends upon the skill of the operators, and is therefore less reliable and more expensive than SMT. Before placing the through-hole components, we first cut and bend the leads to the required size. Some components are not just fixed on top of the board, but are mounted on the side. These are called edge-mounted connectors. To combine the advantages of surface mount device and through-hole technology, some applications require mixed technology components. Most common are USB connectors that need to be mounted on dense boards with little free space. So these are optimal for SMT technology, but need a good mechanical stability, only possible with through-hole leads. To mount such components, we use a pin-in-paste technology. We explain this process in another episode.